Okay, so the first thing I want to do is I want to go through how to rewrite a terminating decimal into a rational form. Okay, so again, you're just going to watch here, and then I'll have you do these on your own. Okay, so if we want to convert and identify why is a terminating decimal considered a rational one, there's going to be several steps to doing that. So I'm going to take terminating decimal. Terminating means it stops or it ends, right? So take a terminating decimal. The first step that you're going to look at is you're just going to write your digits without the decimal. Okay? So you're going to write those out. Okay? If you imagine here you are erasing this last decimal right here. Okay, so erase that. And you're just going to take that mark by itself, the digits by themselves. Okay? Your second step, once you write just the digits and erase the decimal point, you're then going to divide that by 10 to the power of whatever number of digits there are after the decimal. So right here, you see this is 1, 2. So when we're counting our n value here, so you're going to divide by 10 to the n. That's your second step, okay, where n is this number. Okay, so here, when we write it out, we get 10 to the power of 2. Okay, and so that is your answer. Your final step is just to simplify. And when you simplify 1052 over 100, cancel common factors, and you get 263 over 25. Okay, and so this is your rational form. So you're able to rewrite this and put it into a form that has a single fraction that's a ratio of 2 integers. Okay, when you come across these answers, this form right here will be marked incorrect on this. This is one of those rare cases where it will tell you to specifically put it into the reduced form. So you do have to reduce it. All right, so what happens if you have a decimal that repeats? It continues. It doesn't stop or have an end. If that's the case, so if you have these non-repeating, again, as long as they, let me go non-terminating, but repeating decimal. Okay, it has to repeat. If it doesn't repeat, it's an irrational number. Okay, so let me kind of go back. Here, if you have a decimal, even if it has a pattern to it, so 1, 1, 2, 1, 2, 3, ... Even though you could identify the very next digit is 1, and then 2, and then 3, and then 4, you can predict that. That doesn't have a repeating decimal. It just has a pattern, so this would still be considered an irrational number. And if you have decimals that have no pattern at all, still considered irrational numbers. Okay? So if you take one of those non-repeating or non-terminating but repeating decimals, okay, and you want to convert it into its rational form, you're going to do so using the following. So here I'm going to start with 0.5 repeating. So if I have 10.5, the way that you're going to start with this is step 1. Okay, you're just going to write an equation, x equals whatever your original number is. So you're going to just turn that into an equation. Okay, what you're then going to do is you're then going to, again, looking at n. N's going to be the number of digits that repeat. So in this case, there's only one digit that repeats. Okay, you're going to multiply both sides by that 10 to the power of n. So our second step, instead of dividing here, you're going to multiply by 10 to the power of n. And that's going to give you the new equation. And I'm just going to move it up here. 10 times x is 10x. 10 times 10.5 repeating moves the decimal one place to the right. So you get 105.5 repeating. Okay, so the repeating digits will always be the same. Okay, that then takes you to the third step. In the third step, you're simply going to subtract straight down these columns. So 10x minus 1x is 9x. Here, subtract down these columns. 105.5 repeating minus 10. The 105 minus 10 is 95. And again, what you're going to find right here is that this part right here is going to completely cancel. Okay? What you should see is that these parts right here are going to get wiped out. They should be exactly the same. If they're not exactly the same, then you didn't choose the right n value here, but you need those to align so that they cancel completely out. Okay, and then that takes you to the final step, which is to solve for your x. When I divide both sides by 9, I simplify my fraction if I can. In this case, I don't have to simplify it. I get 95 over 9. That is my rational form. Okay, there's nothing that can cancel or reduce from this. All right, so the first one, when you're dealing with a repeating decimal. Okay, so I'm going to go ahead and just put that on the wall as well. So in this first one, when you have this repeating decimal, your first step is just set up an equation. X equals that. And I'll do it down below here. So set up an equation where x is equal to the original value, including the repeating digits. Okay, now, even if you happen to be, these are written with 363636 ... rewrite it with the bar across the top to indicate the repeating digits. Okay, once you establish that, you identify how many digits are repeating. In this case, there's 2 repeating digits. So what I'm going to do is I'm going to take 10 to the power of 2, which is 100, and I'm going to multiply that by both sides of this equation. So if I take this equation and I multiply it times 10 to the power of 2, I get 100x. And here, when I multiply by 10 to the power of 2, it moves the decimal 2 places to the right. So I get 1436.363636. Again, that pattern of 36 will continue. So as I move the decimal here, it will still have a 36 after it. Okay, and then my final steps here are to subtract straight down these columns now. 100x minus 1x is 99x. When I subtract down here, these repeating digits are going to cancel. Okay, and I get 1436 minus 14, so that gives me 1422. And then I divide by 99 to isolate and solve for my x. And here's the case where you might use your calculator to simplify. And so, okay, so when I set this up and I use my calculator here, I get 1422 divided by 99. It'll simplify that for me. I get 158 over 11. Okay, so this is my rational form. It's a fraction of 2 integers. Okay, and if I wanted to verify this before I hit the submit button on whatever question I'm entering, what I would do is just go into my calculator to display on the T89 to display a decimal form. If you hit the diamond button or you put a decimal into your question itself or the problem itself and hit enter, it'll give you the decimal form. And so you see here 14.363636, and that is what I wanted, so it confirms that this is the correct answer. Okay. The second problem is a little bit easier to do, but here's the difficulty is that you guys kind of get focused on doing these steps here, that you forget to realize that this isn't even a repeating decimal. This is a terminating decimal. So all you do for a terminating decimal is you write your digits, 1568, disregard the decimal point, divide by 10 to the power of however many digits fall after the decimal. So 1, 2, 3. Okay, so really this is 1568 over 1,000. You don't even necessarily need to write that out. because if you take 1568 divide by 10 cubed, you can use the original form if you want. Hit enter. It simplifies for you 196 over 125, and that would be your rational form there.